Hello team! With this lesson we start learning Apache Maven. In this lesson we'll recap main features of Maven and we'll identify advantages of it. We already had an overview of different build tools, but in this lesson I'm going to explain you Maven core concepts in more details. We'll talk about Maven Lifecycle, Maven Phases, and Maven Goals. I will explain such key principle of Maven as convention over configuration. And at the end of the lesson, we are going to install Maven on your local computer and configure environment variables. Let's start our lesson. We already hold a high-level overview of different build automation tools and reviewed the advantages of different tools. Let me just quickly remind you some of them. Together we can understand why Maven can become our choice. Maven can provide benefits for your build process by employing standard conventions and practices to accelerate your development cycle while at the same time helping you achieve a higher rate of success. Some of the key Maven features are simplicity. One of the key goals of Maven is making the build process as simple as possible to facilitate the development process. This is achieved by avoiding as many configurations as possible by supplying project templates that are called archetypes. Also, the main Maven principle, convention over configuration, helps us to avoid manual configuration by just following agreed naming conventions. Dependency management. Like some other build automation tools for Java, Maven supports dependency management out of the box. What does this mean? This means that with the configuration we can specify all required external dependencies for our project, and Maven will manage these dependencies. Namely, it will include dependent libraries into the final project build, it will be in charge of automatic updating, downloading them, including downloading sources, validating compatibility, as well as managing transitive dependencies. That is really amazing thing about Maven, especially that this is done in very simple and intuitive way. I am going to show you how to manage your dependencies with Maven in this course. Central repository system. One of the biggest advantages of using Maven is its central repository system. The development community agreed that Maven Central is one of the biggest repositories with libraries, and creators of different products upload their libraries there. Now, let's review Maven core concepts. The core concept in Maven is Project Object Model. That's what POM stands for. Maven has its main configuration file, configuration script, which is called POM XML. If you have never worked before with XML extension, I can very briefly say that this is extensible markup language that uses tags to describe information. POM file contains information about all our sources, including external dependencies, plugins, details about packaging type, and a lot of different other things. The POM file should be located in the root directory of the project it belongs to. On the slide you can see an illustration of how Maven uses POM configuration file and what POM file primarily contains. When we execute Maven command to build the project, we need to pass the reference to POM XML file that Maven will analyze. Maven will execute commands on the resources identified in POM file. Usually we call Maven command in the directory where POM file is located. Some of the actions that may be done by Maven after reading POM is downloading external libraries into local repository. Maven creates a folder on your computer that is called .m2. Maven downloads all required dependencies there. If the dependencies are not found in the local Maven repository, Maven downloads them from its central Maven repository and puts them in your local repository. You can also specify which remote repository to use for downloading dependencies. All this will be explained in more details later in this course. Maven executes life cycles, build phases, and goals. The build process in Maven is split up into build life cycles, phases, and goals. A build life cycle consists of a sequence of build phases, and each build phase consists of a sequence of goals. When you run Maven, you pass a command to Maven. This command is the name of a build lifecycle, phase, or goal. If a lifecycle requested is executed, all build phases in that lifecycle are executed. If a build phase requested is executed, all build phases before it in the predefined sequence of build phases are executed too. Build plugins are used to insert extra goals into a build phase. If you need to perform a set of actions for your project which are not covered by the standard Maven build phases and goals, you can add a plugin to the POM file. Maven has some standard plugins you can use, and you can also implement your own in Java if you need to. Build profiles are used if you need to build your project in different ways. When you need this, imagine that different configurations should be applied for application that is going to be deployed on development environment, QA environment, or production environment. I want to say important thing, and please remember it. Having different configurations for different environments is not always a good practice. Why? Because you increase risk of appearance of some defects related with configurations on upper environments. Yes, having the same configurations on all environments very hard to achieve, but you should minimize the differences as much as possible. And Maven helps you to configure two different builds. To enable different builds, you can add different build profiles to your POM files. When executing Maven, you can tell which build profile to use. Also on the slide you can see high-level structure of POM file. The POM file describes what to build, but most often not how to build it. How to build it is up to the Maven build phases and goals. You can insert custom actions, goals, into the Maven build phase if you need to. Each project has a POM file. The POM file is named POM.xml and should be located in the root directory of your project. A project divided into subprojects will typically have one POM file for the parent project and one POM file for each subproject. This structure allows both the total project to be built in one step or any of the subprojects to be built separately. You already heard, like I mentioned, Lifecycle. Let's learn and understand what this concept is about. Build lifecycle means that the process for building and distributing a particular artifact, project, is clearly defined. For the person building a project, this means that it is only necessary to learn a small set of commands to build any Maven project, and the POM will ensure they get the results they desire. There are three built-in build lifecycles: default, clean, and side. The default lifecycle handles your project deployment, the clean lifecycle handles project cleaning, while the side lifecycle handles the creation of your project's website. And like you already may guess, build lifecycle is made up of phases. Each of these build lifecycles is defined by a different list of build phases, wherein a build phase represents a stage in the lifecycle. In attachment to the lesson, I am going to provide you with the reference to the official documentation that describes all phases for different lifecycles. And for the sake of example, let's review some phases in the default lifecycle. Validate. Validate the project is correct and all necessary information is available. Compile. Compile the source code of the project. Test. Test the compiled source code using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Package. Take the compiled code and package it in its distributable format, such as jar or var, for example. Verify. Run any checks on results of integration tests to ensure quality criteria are met. Install. Install the package into the local repository for use as a dependency in other projects locally. Deploy. Done in the build environment, copies the final package to the remote repository for sharing with other developers and projects. These lifecycle phases, including that are shown here but we didn't talk about, are executed sequentially to complete the default lifecycle. Given the lifecycle phases above, this means that when the default lifecycle is used, Maven will first validate the project, then will try to compile the sources, run those against the tests, package the binaries, and step by step till the end of the lifecycle. During the course, we will use these lifecycle phases. However, even though a build phase is responsible for a specific step in the build lifecycle, the manner in which it carries out those responsibilities may vary, and this is done by declaring the plugin goals bound to those build phases. A plugin goal represents a specific task, finer than a build phase, which contributes to the building and the managing of a project. It may be bound to 0 or more build phases. A goal not bound to any build phase could be executed outside of the build lifecycle by direct invocation. The order of execution depends on the order in which the goals and the build phases are invoked. On the slide, you can see an example. The clean and package arguments are build phases, while the dependency copy dependencies is a goal of a plugin. If this were to be executed, the clean phase will be executed first, meaning it will run all preceding phases of the clean lifecycle plus the clean phase itself, and then the dependency copy dependencies goal before finally executing the package phase and all its preceding build phases of the default lifecycle. Moreover, if a goal is bound to one or more build phases, that goal will be called in all those phases. Furthermore, a build phase can also have 0 or more goals bound to it. If a build phase has no goals bound to it, that build phase will not execute. But if it has one or more goals bound to it, it will execute all those goals. A Maven plugin is a group of goals. However, these goals are not necessarily all bound to the same phase. One of the key concepts that stands behind the whole Maven philosophy is convention over configuration. Probably this is not the first time you hear about this concept. I did high-level overview in our general lesson about build automation tools, but it is time to dive deeper. The concept is simple. Without requiring unnecessary configuration, systems should just work. Maven incorporates this concept by providing sensible default behavior for projects. Without any additional configuration, there is an assumption that following items are located in the related folders, namely, like you see on the slide. Source code should be placed in the src main Java source folder. Test source code should be placed in src main test, and so on. POM XML file is located on the top level. The target directory is used to house all output of the build. Maven assumes that you want to compile bytecode to target classes and then create a distributable jar file in target folder. While this might seem trivial, let's compare Apache Maven with Apache Ant in order you could feel the difference. Consider the fact that most Ant-based builds have to define the locations of these directories, and they should be defined manually by developer, and commands to compile code and store compiled classes there. That is also a piece of script that should be written manually, and doesn't ship with any built-in idea of where source code or resources might be in a project. You have to supply this information. If you follow the conventions, Maven will require almost zero effort. Just put your source in the correct directory and Maven will take care of the rest. Maven's adoption of convention over configuration goes farther than just simple directory locations. Maven's core plugins apply a common set of conventions for compiling source code, packaging distributions, generating websites, and many other processes. One side effect of using systems that follow convention over configuration is that end users might feel that they are forced to use a particular methodology or approach. While it is certainly true that Maven has some core opinions that shouldn't be challenged, most of the defaults can be customized. For example, the location of project source code and resources can be customized. Names of jar files can be customized, and through the development of custom plugins, almost any behavior can be tailored to your specific environment's requirements. If you don't care to follow conventions, Maven will allow you to customize defaults in order to adapt to your specific requirements. Great! We learned some theory about Maven already, and I feel like you are getting more and more familiar with it. Let's now have a live demo, and I will show you how you can install Maven on your computer. I need to say that now, in this video, I am going to show you how to install and configure Maven on Windows operating system. If you have Mac OS, don't worry, you can find special guide in attachments to the video about details of installation on Mac OS. The first thing that we need to do, we need to download Maven binaries on our computer. You can start by searching in the internet these keywords. Download Maven. That's it. One of the links suggested will lead you to Maven Apache org page to the download one. Depending on your operating system, download the archive with binaries for your system. I have Windows operating system, that's why I will download zip archive. The archive is not too big. It is not GDK. Once you downloaded the archive, extract it. And in the bin folder, you can find MVN application. That is our Maven. Similar to configuring paths for Java, we need to configure Maven. Let me remind you quickly. Find environment variables in your startup menu. Click environment variables here. I have a Russian version of Windows, but you will see environment variables title here. After that, create Maven home variable that will lead us to Maven folder. Attention! Not yet to bin folder. To create new variable, click Create, write MVN home, and after that paste path to Maven folder on your computer. After that, we need to edit path variable. Find path variable and click Edit button. We need to add reference to MVN home/bin. In order we can reference to the Maven from any place in our directory tree. This is very important, because most likely a lot of commands for Maven you will invoke from console. Yes, integrated development environments have buttons and views to work with Maven. But you can compare this to interactive tools for working with Git. If you're experienced Git user, you can understand what I'm talking about. Namely, flexibility and level of things that you can manage via interactive tools and command line is different. That's why I need to make sure that you configured Maven in environment variables and you will be ready to use it from console. Once you made all necessary changes, click Apply and close all these windows. Now, let's open command line to make sure that we configured Maven properly. Let's navigate one level up from the folder where MVN is stored. This is important, because we need to check that MVN command will work from different directories, not only from the directory where Maven application is located. Okay, when we navigated one level up, I typed cmd here to open command prompt. And here I call Maven program with version option. I type mvn space dash version and press enter. And here is latest version of Maven that we configured is displayed here. Great! This means we configured Maven properly and we are ready for the following lessons. That's all for this lesson. Let's recap what we have learned today. Today we learned why we need Maven and its main features. Also we learned basic concepts of Maven and you understood what Project Object Model is. Also we discussed Maven lifecycle, phases and goals. I explained you what convention over configuration principle means and we learned basic POS in Maven convention. And at the end of the lesson we downloaded and installed Maven on your local computer. Now we are ready for the following lessons. Thank you all for your attention. Have a great day and see you in the next lesson.